I'm good. You can start.
All right, thank you. Your voice is not very clear. I don't know if it's your microphone or the network, but I think we're good. So, hello everyone once again. Okay, I think I was actually sharing my screen. It seems like I am not sharing my screen just yet. Okay, so let me share again. Where is it? Share screen. Share my entire screen. Okay. All right. Confirm if you can see my screen too. I think I need to delete some of these things. Give me a second. I have to save this locally. Bank stuff. All right. Yes, I can see your screen. Thank you very much. So today we are going to be covering databases. Of course, if you are part of the 300 Dev Days program, then you know for sure that we've covered the databases before. At least, we've looked at the fundamentals. We've been able to try out a couple of examples, especially using NoSQL, right? We tried out MongoDB. NoSQL is basically a pattern or a type of database, right? And we were able to try a specific platform or a specific, database platform that was built around um, the NoSQL model. I think someone just dropped a message. Let me see. Hi everyone, I'm new. So hello, love it. Okay. I see that you are new. If you have any questions, if you don't understand what we're doing here, then you might want to check out some of our previous sessions on YouTube. But yeah, you can always circle back to this video, okay, because it will be shared in the channel here. All right. So we've been talking about databases, and of course, most of you probably understand what we mean when we say databases, right? I'll give a very realistic example here for those of you that are probably new. So let's assume you use an application. Everybody here probably uses Facebook, I believe, or yeah, I think Facebook is a good example. So let me use Facebook as my example here. I'm going to be dropping some, definitions, but it's mostly going to be hands-on practicals. Okay, so we use Facebook, right? You use Facebook, you sign up, so you are a user on Facebook. You have an account, right? Which is what most of us call it. So you have an account. Facebook see you as a user because you are registered on their platform. And when registering on the platform, on Facebook, you have to, of course, follow a set of process. So, say number one, you have to open the Facebook website. So right now, I'm just trying to, show like a list of processes, right, using Facebook. So most of us are familiar with this. Okay. So you open the Facebook website. Number two, you probably click on sign up, right? Number three, you put in your information or your credential, right? Let's just call this your information. Now your information can be maybe your first name, last name, email and password, right? And of course they ask you to confirm the password. Let's just say confirm password. Now some of this flow might not be exactly the same thing, but that's not the point. We're just trying to make sure you understand the steps here. So you put in your information, including your credential. The purpose of that credential is to say that I want to be able to use this email and password to log in when next I come into these websites. Okay, and of course you are sharing your first name, last name, with this platform so that others, right, other users will be able to identify you when they visit Facebook as well, right? At some point, they recommend that you upload your picture. You put in a lot of details, but let's leave that for now, right? This is a set of information you're going to put in when you are creating this account, right? So I'm using this as an assumption, by the way, because it must not be exactly the same thing. So let me just make this clear. Assumption, creating a Facebook account. Okay, so it's an assumption. All right, so when you put in this information, Facebook needs to store your information in a place, right? So it is, safe to say that database is, a storage, right? It basically falls under storage because you are storing data. Now, I don't want you to confuse this for a different type of storage, but I will get to break this down even further. The point is we are basically saving data, right? The type of data in this context, of course, would be some textual data, right? It can also go beyond that, but I will basically put this in such a way that it will be easier for you to understand. So let's just say we call this structured data, right? I'll get to talk about this even more, but textual, let's say, or structured data, right? Saying data that we have actually structured somewhere. We've written it down in such a way that we can relate with that data or understand that data, right? Because we put it there, right? It's not a file, at least for now. It's not a file. It's not a video. It's not a music. It's a text, right? Information. It's a text information. First name, last name, email, password, and of course, let's just stop at password, right? First name, last name, email, and password. Okay, so the process of Facebook storing this information, let's put a different box here. So I'm going to say this is Facebook database, right? We'll call it a database because this is where Facebook store their customer data. So this is where Facebook stores the customer data. All right. This can be a different type of database. We're not going to look at the exact type, but we want to focus more on the meaning of what this is doing for Facebook. Now, this is you. Remember, you visit the Facebook website. When you visit the Facebook website, you are asked to put some of this information that I mentioned here, right, into the website. So you are asked to put this information. And when you put this information right into the Facebook website, it is going to store this information into the database. Now, of course, other things might be involved in the midst here. So, for example, you can have like a backend API and all that. For those of you that have been part of my sessions, for the past probably 8 to 10 months now, I think you are already familiar with, what an API is, right? So I'm just going to put this here. And if you don't know what an API is, please do well to drop a message in the chat. I'll just give like a quick explanation, but I'm sure you can find other videos on YouTube, on our YouTube channel that explains that even better. So we have the Facebook website, we have the API. Basically, the API here is just sitting as a middleware. So let's just say this is just a middleware between the Facebook website and the database, right? Or let's just say a connector, so that you don't, get the terms. You don't get to mix this up here. Okay, so let's just call this a connector between the website and the database, which means the website is going to pick up this information that we've dropped here. It's going to send this information to the API, right? The API is going to do some, validation. The API will check if this user is not existing already in their database. That is why when you create an account and you try to create an account again with the same email, it goes to the database to check, and it's going to say, is this user already in our record, right? So that is what is going to happen here. It's going to check, is this user already in our record? That is the question that it gets to ask the database. If it says yes, it is going to come back and tell you that, oh, sorry, we already have a record with this email or with this phone number, right? So we can't accept this detail again. You have to use a different email or a different phone number. Okay, that record is already stored here. And if it's not in the database already, it's going to proceed to create a new record, and it will come back to you. The API will come back to you on the front end to say, this record has been created successfully. Please go ahead to verify your phone number or your email. right? I'm just giving an example. At the end of the day, the point here is that the database is used for storing that record. And when next you come back to the website, you can simply retrieve the record or your information, including your friends list, including your, the notifications, the updates, right? Some of the information you have on your feeds. Okay, so all those records are in the Facebook database. All right. So I hope that makes sense from a practical example. Someone is asking, do database grow? Yes, if you are talking about growth in size, if that is what you mean, but maybe you can add more context to that if that is not what you mean. If you are speaking about the size, right? Definitely yes. So the Facebook database, for example, let's assume creating this record, we had nothing in here. So let's say this was probably just a few kilobytes. So let's just say 100 KB, for example. Okay. Over time, if we have like 1,000 or maybe like 10 million. So if we have 10 million records, I mean, right now for Facebook, we're looking at, trillions and trillions of storage, right? Amounts in terms of the amounts, in terms of the size, right? Probably it's a lot already, right? So we're looking at a lot of data, and that would have taken up, lots of storage already. So yes, in terms of the size, right? Data. So in terms of the size, this is going to grow. And, when we get to talk about scaling databases, we'll basically look at, vertical, we'll look at horizontal, we'll look at vertical, horizontal scaling when we start talking about scaling. And we'll also look at how to partition, our databases as well, right? So I would explain that to you instead of, scaling a single node, we call it a node, instead of scaling a single node into like, instead of scaling the size, continuously, you can always set up partitions, right? You have different data stored in different partitions. So there are different ways to approach that. But yes, databases grow in size, and there are ways to approach, the scale. Okay. So back to the basics here. I was someone is saying, please, you need to explain NoSQL and MySQL. Oh, definitely, definitely. I mean, we are going to have that covered with practical examples and even code examples. So, you pay attention, and we'll definitely get to that. Okay, so that was just a very simple scenario-based explanation. At least to make you understand what we mean when we say databases. Okay, so a database is an organized collection of data, and it will generally store this data in an electronic form so that you can also access this data after a while. Okay. So let's just put in a very simple definition here. For those of you that might want these, maybe like a screenshot, or you want me to drop like, a copy of this material here. So the question, what is a database? All right. So a database is an organized collection of data, right? That can be accessed. So accessed programmatically. Okay, so when I mean programmatically, I mean it can simply be through a console. It can be through a GUI, which is an application. It can be through your code, right? There are different ways. At the end of the day, you are accessing it through a specific channel, right? Or a channel. So you are accessing this particular data through a channel, which means you can submit, you can save, you can retrieve, right? Okay. So I'll simply say you can save, or you can create, updates, delete, or retrieve this data accordingly. Okay. So what I mean by that is you can, of course, create a new record, you can delete, you can update, and of course you can retrieve these, records based on your rules, right? Based on the way you've specified, in your code or in your application to work with this data. Okay. So I'm sure most of us here are already, familiar with it, at least a little bit of programming, whether you can write, SQL or JavaScript or, Python, whatever language it is. What we have been looking at for a while now is JavaScript and, Express.js for the framework. So we're going to be trying out some examples using JavaScript in today's session. And if you are a Python programmer, I can point you to, like the direction on how to go about using databases in your application. Okay, please mute yourself. If you have a question, drop it in the chat. I would see your message. Then I would ask you to speak. Okay, thank you. So, speaking about the types of databases, all right. Speaking about the types of databases, we have several types of databases. So we have the relational databases. Okay, so we have the non-relational, which is what most of you also call NoSQL. Okay, and of course, I mean, this has different names. You hear some people call this document database, right? So it can be non-relational. I think I can just use a slash here, or document DB. Keep this short, so let's just say DB. Okay, so relational DB. For relational DB, this is basically, this basically uses tables. So let's say use tables to store data, right? And what this means is that each table is a collection of related data entries. So I'm going to give a practical explanation to this as well. Let's assume we are trying to build an application for a school, right? We're building an application for a secondary school, all right? And, our expectation here is that one of the modules in our application. So when I say modules in our application, I'm referring to the logical structure, the way we've structured our code, to function, or our application to function. So we have a module for student onboarding, right? And we have a module for parents, right? So in our application, we can create parent record. We're not speaking to a database just yet. This is the application. We want to be able to create parent records. And of course, if we're creating parent record, then, we also want to retrieve these records. We also want to, update and delete. So let's just say update and delete these records. Okay, now this also applies to the student's record, right? So we want to be able to create the student's record, retrieve these records, update and delete these records as well. So now we have, two classes here. The first one is for the parents, right? When I mean class, try to understand the keywords here. When I mean class, I'm basically referring to the categorization here. We have the students and we have the parents. So let's just say the students and the parents. So we can create a student record. We can, retrieve, which is like fetch. We can delete. We can update, right? So these are the actions that are part of these, modules that I've specified here. So this is the module. So we can say student module, parent module, and these are the actions, right, that I've just specified. So these are the actions. Okay, so the actions: create, retrieve, update, and delete. Create, retrieve, update, and delete for students. When you create a new student record, you want to have a way to save this, record, of course. And when you are working with a relational database, I would give some examples. But when you're working with relational databases, you are saving these records in a tabular, form. So your table can be students. So this can be students table. So you have to create a table. Let's call this student table. And within this table, you basically have columns, right? So you have columns, columns. Okay, so before I continue, let me try to, add some context to this. We have our database. We can call this the school DB, right? And we have our table. we can have multiple tables inside your DB, right? So we can have the table for saving the student record. We'll call this the student table, right? We have a table for saving the parents record. We can call this the parents table. Okay, we can have even more tables, but of course with our example, student and parents, so let's stick to this. When you have a particular table, that table will then contain, what we call columns, right? Columns is simply referring to the items that you're trying to capture inside that particular table. So for example, the students will have like name. Maybe we can break it down to like surname, right? First name, okay, and of course we can map this to a parent, but I'll get to show this shortly. I'll get to explain this better, and I call this PK. PK stands for primary key, so I'm going to explain this, right? Sorry, this PK was supposed to be right here, so let's call this an ID, student ID, primary key. I will explain what I mean by primary key, and I would also explain what I mean here, which is I would call this a foreign key. But these are, tables, right? These are columns inside the table. Okay, remember the name of this table is the student table, and these are the fields. So when we are creating a new student record, we should be able to, have a student ID, which is expected to be a unique ID. Every student would have their own ID, right? You don't want three students, sharing the same ID. It's no longer unique. This is a way to identify each student. If I am a student in that school, I have an ID of 001, for example. If Amaka is in that same school, Amaka cannot be having a student ID of 001. Just like most of us, you know what your matriculation number is. That is kind of like a unique ID, because you will not have exactly the same matriculation number with someone else, right? So that is an example of what I mean by primary key, which is a unique ID, right? A primary key is, a primary way for you to identify a particular record in your table. Okay, so this is a unique record. Student ID, it's that identifier that we are referring to. Okay, every student would have a student ID, a surname, a first name, maybe an optional middle name, right? Then the parents. How do you map the parents of the children to each of those records, to each of those children? How do you want to do this mapping? Because basically, parents can have 2 or 3 children in that school, right? And that is where the foreign key comes in, because the parents would have their own table, and I would get to explain. I would show the parents table, and I will show what I mean by this foreign key by mapping that relationship between the two tables. Okay, so we have the first name, we have the middle name, we have the parents. We can also include so there are so many records we can include here. I'm just going to stop by I will just add the class, right? So let's just add the class. Okay, so this is going to be arranged and structured in form of a table, right? And these are the columns. Okay, these are the columns we have inside that table. When you are creating a new record, you're going to fill in each of these section, and at that point of creation, we can refer to these as the fields that we are basically passing information into. Okay, to show you an example, I have a database here. Let's try to connect to my local database, and I'll show you a quick example of what a relational DB table would look like. Okay, so I have a lot of samples here. I think this is on Elephant SQL. I don't know if this is still going to connect, but let's test. All right, so this is not connecting. I think these are simply old records, but I should be able to connect to my local machine. So let's go ahead and open up my database. Don't worry about the database type. I will explain some of these things to us. We still have 2 days to go through this session. So let's see if I am connected. All right, so I can connect to my local database. I have a sample table I have created here. So basically, you see, this is a table, what you are seeing on my screen. Let me zoom in so you can see this clearly. Right, this software is called Beekeeper Studio, and within this software, I am actually showing you a Postgres database, with a table. So I have a database here that I'm showing you. I have a lot of databases here. So you see, we have a HRO manager, for example. I can click on that database and let's see if we have anything in there. I'm not very sure. Okay, so we have account table. All right, so you see we have a sample table in here. We call this the HRO manager database. And inside this database, we have two tables. We have the name table and the account table. This is just an example. Within the account table, you see we have the ID. As I mentioned, the unique identifier for the records, right? We have the date that this record was created. Okay, so we'll call that created at. You see, this is a tabular, a structure. So here we have the name, right? We have Marriott, Mark, Bob, and you see we have emails, right, for each of these records. So this is record 1, this is record 2, and this is record 3, right? These items are stored in our database, and we can simply store more records or retrieve, records from here. Okay, so let's go back to our drawing section here. So I'm going to create the second table. Let's call this table the parents table. All right. So if we have the parents table here, we can have the parents ID, which is also a primary identifier, because you have unique parent records, obviously, right? You have unique parent records. And remember I mentioned that we have a foreign key. A foreign key is basically a type of key that shows the relationship between tables, right? And there are different ways to map this relationship, but just to keep it high level and simple for now until we get to a more advanced topic, or probably before the third day we can discuss more details about this type of constraints and relationships, right? For now it's a foreign key because we're trying to use this as a way to reference the parents of these children. Okay, so for the parents we also have the surname, the first name, maybe we have some other information, probably like the address and the phone number, right? And maybe email, right? So we have like phone number, and then we just have email, right? So that's the parent's email. In order to perform that, mapping, we can simply map the parent's record here to the parent ID. What we are doing by mapping it this way is to say that if a parent ID is 101, for example, it means in this table, in the student table, we are going to have to put 101 right here. So if we have two children, right, or two students, we have two students record. The student records can share, this particular record, this particular parent's ID of 101, meaning that these two students have the same parents, right? So it means these two students have the same parents. Okay, so just to show you what we have done at that moment is create a relationship, right? So it means the student is related to the parent. And how do we identify that relationship? We've done that using a parent ID, which is the primary key in the parent table, right? In this table, it becomes a foreign key because we are using that for mapping relationships. Okay. All right, so we'll get back to this. The point is we just need to understand that for relational databases, we use tables for storing these records. So it has to be in a tabular structure, looking like this, looking like what you're seeing on my screen, right? We'll show some examples on how to, create some of these things. We have to write some code, obviously. We call that SQL. We use the structured query language for creating these tables and performing these insert and delete or update operations. Okay, so we'll get to look at that. Let's go back to our explanation here. Relational databases use tables to store data. We also have the non-relational database. So someone is asking a question. Please, with regards to the foreign key, I think that left my screen already. Give me a second. Let me pull back into Telegram. Okay. All right, so with regards to the foreign key, do we use the primary key of the student table? Yes, so let's come back here. Hold on. All right. So your question is with regards to the foreign key. So this is the foreign key here, which is the FK, and we have the parent, right? This parent that you're seeing right here is mapping this table, and it is identified by the parent ID. So it has to be something unique, something that you can use to maintain, that relationship in this table, right? It must not be the parent ID. It can be something else, but it has to be, unique enough so that you can use that as a pointer to the record in a different table. Yeah, so I hope that makes sense. Who is asking that question? Nana Junior. I hope that makes sense, Nana. Please, do you have any further questions? And yes, if anybody has, further questions, drop questions in the chat because I am looking at the chat, okay? All right. Let me see. Okay, thank you. So let's move on. Let's move on. All right. So speaking about the non-relational databases. So the non-relational databases is designed basically for unstructured data, providing flexibility and scalability, right? So when we say unstructured data, I can give examples of, for those of you that have worked with JavaScript, I'm sure you know what to call JSON, right? So if you know what to call JSON, it's a way of structuring data that we're about to transfer over the internet, primarily using a protocol that we call REST. Okay, the REST protocol. So we have let's say this type of databases is designed for unstructured data, right? Providing flexibility and scalability. All right. So providing flexibility and scalability. So the thing here is for relational databases, we're storing this in tables and it has to be structured. There are some rules. I don't want to start giving a lot of rules. You hear things like your database has to be acidic, it has to be this, it has to be that. That's just a lot of information for someone trying to understand what this is, at least for the first class. So we'll get to talk about this in details. And of course, you can do your research and you can come with some of those questions, things you don't understand while researching. So we'll get to discuss that. So Michael is asking, does the foreign key get updated automatically? So what you're asking, back to this, what you're asking is if the foreign key gets updated automatically. Well, it is a reference. So Michael, this is a reference. So there's no updates happening here, right? When you use that reference, you point that reference to this table and you point it to the specific fields that you want to take this item from. So I can say I want to take this item from the parent ID, right? Which is the parent table dot parent ID. Okay. If a parent that we've created, Michael, let's look at this from a very practical scenario, right? So Michael, you are the person creating these records in the software, right? Within that school. Okay, so I come into the school as a parent and then you log my information. You take my surname, my first name, my address, my phone number, and my email, right? The information we've captured here. And then I have 2 kids and I want you to, enroll those children in the school. Okay, so you go in there to put in the surname, the first name, the middle name, the parents, right? Or say the class first, and then you get to the parents. You don't want to start entering some records that you might end up making mistakes with the name here. Then it means the name of the parent here and the name of the parent of this child in this table is no longer a match. So because of that, we've set up a way for you to click on a field. When you click on that field, you get a drop down, right? So just to show this is not what it will look like, but yeah, so you get a drop down, and when you click on that drop down, we simply want to give you the parents. So we want you to be able to search for the parents you've registered for here, right? So you have a form and you are collecting the student's information. You've taken other fields, right? You've taken other fields already. You've captured some of these other informations, such as the surname and the rest. You've captured this information. When you get here, you just click on that drop down, probably search by putting my first name or something or my surname, then you see the information of that parent, and all you have to do is click on that parent's info. When you click on that parent's info, what we take is the ID of the parent, not the entire thing, but the ID, because when we need to know who the parent of Marvelous Junior is, all we have to do is click on Marvelous Junior information, and we, from our application, we will take the parent's ID that have been stored here. What you are storing here is the parent ID, which is a reference to this table. So it's a foreign key because it's a reference. So if we take the ID, say 101, for example, when we take that ID, we call the parent table and we fetch the parent information with the ID of 101. On that form, we are going to have Marvelous Junior information on one side. And then because we've gotten this ID and we've run that message here, we are now able to also fetch the information of the parents. Now, this does not mean you are creating all these records again inside this place. You are only storing the reference, which is that ID. So this is the ID that we're using for this example. That is the only thing you are storing here. And based on the way you've created this table, it knows that we are trying to store a foreign key. A foreign key means that we are trying to store a record that is pointing to another table. All right. So Michael, hope that I think, is Michael dropping this message in a different place? Michael, you're dropping your message in a different channel. That is not the Top Universe channel. Okay. So Michael, please, if you have more questions, drop it in the Top Universe 300 Dev Days channel. All right. Thank you. Okay, so Michael, if that is not clear enough, you can ask again or tell me what is confusing you, so I can explain further. All right, so back to this, we have non-relational DBs that I was explaining, and I said this type of database is designed to store unstructured data. So if you have a JSON object would look something like this, So we have maybe name. All right, we have maybe class or level, department. So let's say department computer science, for example. Okay, we have level 300, say 300 level. We have name, Marvelous, Solomon. All right. Okay, so this is an example of a JSON object, right? And we can refer to this as an unstructured data because sometimes we can store a record that looks like this for the first user. For the second user, we can have a record that also includes maybe hobbies. All right. Now you see that at this point we did not create a table per se. So dancing, singing, cook. Oh, dancing? No. So this is cooking, coding, etc. All right. So we can have two records, and in this case we don't call them tables, right? We don't call them columns. We don't call them fields. What you're seeing here in a case of non-relational DBs, we call these records. This record you're seeing here, we call these documents, right? So in non-relational DBs, we call these documents. Okay, and then these documents are going to be stored inside what we call a collection, right? So each of these documents will be stored together, right? They will be stored in a place that we call a collection. All right. So come down. So let's put that here, a collection. So the collection, is going to be, what we call a table in a relational databases, right? So a collection basically holds all these things, together. So we can have a collection look like this. Okay. So now this is our collection. Our collection here can be a student collection, right? And the student collection would hold these documents. So these are the documents right here. Okay. These are the documents right here. All right. So note that in non-relational DB, we don't have tables, right? We have collections. Okay. Collections hold the records, and the records are referred to as the documents. And of course, within the documents, you basically have, these items or these fields. Okay, so you have this field. So yes, I want you to understand that we can basically do some mapping here to understand the difference. I mean, in terms of the name and how they are related. We have a table in relational DBs. The equivalent of that in the non-relational DB is collection. Yes, someone said, are there rules to follow in non-relational DBs? Well, in terms of how you save the records, as opposed to the relational DBs where you have to define those columns, and of course you cannot put something in a column that is not defined, which means it must have a structure, right? Of course, even here you can also specify more rules. I mentioned that earlier. I call them constraints. So constraints is like saying, I want this to be able to accept null, or I don't want this to be able to accept null, right? I want this to be an integer, for example, like a number, but you would call it an integer. There are different ways to basically, specify what to call. We call them the data types, right? It can be a string, which can be like varchar, right? It can be text. It can be a boolean, right? True or false data. So, I mean, there are different ways. And of course, it depends on the specific platform you're using, right? If it's Postgres, if it's MySQL, if it's Oracle DB, if it's Microsoft SQL, they have different data types that are specified in these, databases. But then SQL, it still follows the SQL standards or the rules, right? SQL stands for Structured Query Language, and it specifies how these, tables and columns should be created. So you have the table, and then it says in the column, you should always specify, the column name. You should specify the constraints. So the constraint is to say, is it unique? So for example, an email in an authentication or a user table should be unique, because you don't want two users using the same email, right? Else it would cause a problem, right? You don't want two users using the same email, so you can set constraints, right? This is an example of the constraints. So a table name, for example, a column name, for example, can be email, right? The constraint, we can set that to unique, okay? And of course, the data type, we can simply say we are, expecting a voucher, right? A voucher, we can put a specific size. We can say 50, we can say 150. So you can put a size of, what can go in to that data type, okay? So this is basically, some rules and some, specifications when you are creating a relational DB tables and columns, right? So keep that in mind. I think I'll probably keep this here. But when you are working with non-relational, you don't specifically need to set, that structure. Although in some programming languages, they tend to give you, some libraries that can help you specify some structure if you want, if you want a structure. But the database itself does not restrict you. So you can have one record with just 3 fields, just like what I've specified here. You can have a different record with 4 fields. You can have another record with 20 fields, and you don't get that that error telling you, oh, we don't know these columns, we can't accept it, right? So here it accepts all of them, whether you send in with just one record. But then if you use like Node.js, for example, with a tool like Mongoose, let's say you're working with MongoDB. Now, MongoDB is not the only non-relational DBs. We have a lot of them. We have Cosmos DB, we have Cassandra, we have a lot, right? Even down to using Redis. These days there's a tool called Redis. It gives you a persistent storage option, right? It's called I think you can even use a library called Redis ORM. But the point is that we have a lot of databases, right? Relational or non-relational, we have a lot of them, and depending on the one you use, if it's relational, it follows that, it follows some structure, some standards that you should adhere to. If you use non-relational, it is easier for you to just, use without necessarily going through saving or, applying those rules. So of course you can break those rules there, and your database is going to work. The only thing is you then need to understand, you need to understand what you're doing. You need to pay attention to the, to what you're creating, so that you don't get confused at some point. So to most people, setting up the standards, knowing what they can put into a database and what they can't put is good for them. In the financial space, for example, nobody would actually allow you to store financial information this way, right? Because it has to be standardized. Okay. So in the enterprise space, most times you find them using relational, right? But then, in startup space, retail, and some of these industries that don't necessarily, require those, level of strictness, they can, of course, use non-relational databases. Okay, so those are just, examples. I was trying to map, how they relate. So a table can be seen as a collection in NoSQL, right? A table in what's it called? A relational database can be seen as a collection in non-relational database, right? And a column here. So can have a column, right? A column here, can be seen as a field here. Okay. Now a record in relational databases is like a complete set of record for a particular user or a particular student, right? Just like what we saw here. So if you have all the information in here put together and you save that information, you have a record, right? And the record is a collection of multiple items or multiple columns, multiple field columns, right? Columns with data put together. Okay, so we have a record here, and a record in NoSQL will be seen as a document. Okay, a document. All right, so keep that in mind. So at the end of the day, this falls into a database. So of course, NoSQL. All right, let's just say NoSQL DB. And here we can just call this SQL DB. DB, not DV. So DB. Yes. All right, so this is what we have here. And, in SQL, you have tables, record, columns, right? So, within the tables, you have the records, each records, and within the records, you have the columns. In NoSQL, you have the collections, and within the collections, you have documents, and within those documents, you have fields. So, please go ahead and drop more questions if you have them. Drop more questions. Okay, so I hope this makes sense. It gives you some clarity as to what I've been trying to explain all this while. All right, I've also given some examples. Do you want me to give one more example? Maybe like let me know if you want me to give one more example, or if you simply want us to just move into practical NoSQL DB. We're going to be taking NoSQL DB today. I would walk you through installing a sample NoSQL DB and of course using it. We don't have a lot of time, right? As you can see, it's already about an hour, and I mean, I've been seeing 8:35. Oh boy. Okay. So I don't want us to spend more than 1 hour in a class. Reason being that I don't want to create too much complexity. I want you to always at least understand some of the things we've covered, especially in an hour session. I really want us to look into installing MongoDB, using MongoDB, trying out some of the commands, creating some records. But I think it's already 8:56. So if you prefer that, okay, I think there's a question in the chat. Let me take those questions first. Okay, so someone is asking, any difference between a model and a schema? Of course, I'll walk you through that right now. Someone is asking, can you store audio and video files using MySQL or NoSQL? Well, so, these type of files you've mentioned, we call them blob data. So, hold on. We can call them blob data. Right? We can call them blob data. We can also call them object data. Okay, so what we usually use for saving this kind of data, just like what you've mentioned. So you said music, so like MP3, right? Music, video, MP4, formats, right? Even pictures, JPG. The question you have asked: can we save this kind of records in MySQL? I think you meant in SQL or no SQL, right? So in SQL or no SQL. Well, yes. Now, the way we go about that is if you can compress this into is a byte, right? A set of byte data. That is what I meant, like byte data. So more like a string, a very large string with lots and lots of byte data in there that you can simply put together when you are ready to present this data. Yes, you can, right? For example, images like the JPG files. If you have seen what to call, let me show you what I mean. So there's something we call, hold on, byte string. Okay, just give me a second. I'm trying to pull that up. Okay, so I'm trying to pull that up here. So you see we have a byte array. I'm trying to show you something on Quora right here. So you can actually get to store some of these things as a byte array. Now the thing is, it actually takes a lot of storage. So a lot of people would not want to do that. But yeah, you can. You can actually store these things as a byte array. So what is the byte array of an image? What is a byte string? Right? Just like I'm trying to mention, it's a fixed length of array of bytes, right? And you are able to store some records in form of this data. It's a very lengthy string, right? Let me see if I can get a picture showing an example. So it's a lengthy array of strings that can be interpreted to give you the meaning of that picture, right? So when put together, you can get back that picture. A lot of people don't do that. It's not the best way to actually store object files, right? The best way to store object files is to store them in an object storage. Okay, so the best way is to store them in an object storage. So instead of doing this, even though you can, you would prefer to store object data in an object storage. Okay, so an object storage can be storages like maybe some cloud storage platforms like S3, right? If you've heard of S3 on Amazon, Azure Blob on Microsoft Azure, right? So these are platforms where you can store object data, right? Instead of going this route, because this is going to doing this, storing this kind of data in SQL is going to make you spend a lot of money in terms of the cost, because this is going to take up a lot of space. Databases are expensive, and the best way to store this kind of heavy data such as MP3, MP4, JPG would be object storage, because object storage is cheap, right? So keep that in mind as compared to databases, right? Storing objects in this kind of storage facility or platforms is cheaper than going the route where you have to store those kind of data in your regular DB. So please follow this as like a best practice on how to store your files, right? So keep that in mind. Hope that makes sense. Hope you understand me. That is for Kenny John. Lawrence is asking, any difference between a model and a schema? Yes, I said I was coming to that. Of course. So now it depends. It depends on how you basically define this. What exactly you mean by schema and the model? So I remember when NoSQL began to I would say become popular. I had a lot of issues with some of my students, because when they go to YouTube, they see schema and model to be the same thing. But when I try to explain things to them, I make them understand that a schema and a model can actually mean different things depending on the context you're coming from, right? So what I tend to call a model is basically what I use to set up some sort of structure. I can say this is like my business model. I can say this is like my database model, right? So I create this model, and this model defines how I store that record inside my DB, right? This business model defines how I basically perform, or how I've created the blueprint for those actions inside my code, right? Now for schema, Schema is just the shape itself, right? So for example, I can say I want a username, I want a password, right? And I call this my schema. If you come in and then you pass username, password, and maybe age, I can say this is wrong because this is not my schema. This is not what I've defined. If you come in and you just put username without the password, I can say this is wrong. You're not giving me the password. I want username and the password, right? That is my schema. When I've set up this schema, for example, username, password, I can then come to say, use this schema to give me a model, right? Give me a model that, when saving into my DB, right, my records should follow, this new model that I've defined from the schema. Okay, just try to understand that, following this example. I have the model, and this model then, stands as a contract, between the schema that I defined initially and my core database, system, which, for example, can be, MongoDB, right? MongoDB, it can be Cosmos DB. The schema, it's coming from the angle of the data validation and, what the data should look like, how the data should be structured. When I call it a model, it means I have set up that contract with my code. If I'm looking at it from a business logic side of thing, if I'm looking at it from a database side of thing, I have set up this, as a contract between, my code, my application, and the database, right? But of course, using the base structure that I set up that I call my schema. Schema is saying, look like this when you come in. Model is saying, look like this when you save. Look like this when you operate. Okay? So Lawrence, I hope you understand this, right? As you can see, the same, object, definition here, but then, different points of, use, if I can describe it that way. I think that makes sense. Hope that's clear, Lawrence. Let me know in the chat if you understand what I mean, right? So Lawrence, I believe you're probably a JavaScript developer, and if I want to explain that even better, I can use a schema to describe, the validation section of what comes into my backend, right? And I can use the model to describe how I structure my business logic within my code, or how I basically define the contract between my database using Mongoose, for example, and my the expected record that comes in, so which is on the schema level. Okay, so Lawrence, hope you understand that. Drop a message in the chat if you understand me. It's already 9:05, right? It's 9:05, and we need to cover MongoDB, right? The commands, how to basically install it, run the commands, save records, and also create like a simple CRUD application, write enough code, right, to make sure you understand what this is. But we can't do that today. It's already an hour, and if we decide to start that, most of you might find it very complicated already, given the fact that we've said a lot of things on this session. We've covered things like this before. I remember clearly explaining, databases to you. Now I've written a bunch of things here, and most of you might want, these screenshots, but it's just scattered everywhere. So please do me a favor, watch this video again, understand it, and come to tomorrow's session with your questions. We're going to be writing code tomorrow, right? We'll spend the first 30 minutes writing code, which is NoSQL code, MongoDB code, showing practical example of how to create some of these records, right? And the remaining 30 minutes from tomorrow's session, we are going to learn a little bit of data modeling, right? Database modeling. We're going to be creating some data models, showing relationships. I'll teach you how to use some tools to create some of these data models. We're going to be learning a little bit of diagramming, so that on the third day, we can now, dive into SQL, which is, of course, structured query language, write some queries to create tables, create records, and someone said, I thought we have had. Yes, we have. Of course, Kenny John, we have had sessions on MongoDB. So maybe some of you can just head to the YouTube channel, do me a favor, bring those videos here so that people can watch those videos before the session for tomorrow. So we have had those sessions. That is why I want tomorrow's MongoDB session to just be 30 minutes for those that have not been following, so that we can then focus more on relational databases, primarily using Postgres as our example. Okay, thank you very much, Kenny John. Thank you, Lawrence. Thank you, every other person on the call. Thanks for joining in. I'll see you tomorrow. I hope you had a wonderful session this evening. Let me know in the chat if you did. If you have questions, drop them in the chat and we'll take them in the next session. Do have a wonderful evening, guys. I'll see you next time. Yeah, have fun.